Welcome to part 9 of solving mazes with reinforcement learning. So in the last video we were into a couple of problems with our training as well as with TensorBoard. So we're going to solve those and then move on to our test method so that we can actually see what the agent's doing. So first off, we hit some issues launching TensorBoard. In the last video I got an error there. Fell back, took a look at it, and the problem is we did not have matplotlib installed. So I went ahead and added matplotlib to my requirements.txt. And then installing that is as simple as pip install -r requirements.txt. All right, so now I have all my requirements loaded. I am going to go ahead and clear out runs just so we get rid of all that bad data. And I was playing with the episode length there. I'll set that back to 100, and then I'm going to go ahead and run this. And that's going to start getting us some data. Now you'll notice there's a warning here, and we're going to go solve this in a few minutes. So it says using a target size torch 6464 that is different to the input size torch 641. This will likely lead to incorrect results due to broadcasting. And that is accurate. That's going to cause us some trouble later. So now that we've got some data getting generated, I'm going to hit Control-Shift-P and select Launch TensorBoard. And I'm going to say no here and just click Use Current Working Directory. All right, and then that is has launched my TensorBoard here. I'm going to click on Scalars, and then I'm logging a series of different data points here. So my critic loss, my entropy loss, which we're not using at the moment, my policy loss, the alpha parameter, and the reward. And you can see I've got this run selected. I can unselect it and get less data there. Up here, I'm going to refresh for the latest data, and then this little button, Fit Domain to Data, can be useful to actually get this to snap to and show you the real value. Now this is currently showing a point in time. If that doesn't change, we may need to go and tweak some of our return values. But this is really the number we want to look at. This is our training reward, and you'll notice it's just kind of oscillating up and down. It looks a lot like random chance to me. The agent doesn't seem to be doing any learning. So, and that kind of proves out here. There's lots of zeros. There's a few, numbers, but our graph here is what we really want to look at. It's just kind of, up and down. And by the way, if you can't tell, this is a smoothing toggle. So I will usually pull it back if I want to see some specifics, but I do most of my training with this at 0.95 or 0.96 smoothing so that I'm looking at overall trends and not specific values. So the error we saw earlier, this using a target size torch dot size 6464 that is different to the input size. What's going on here is over here in agent, the mask batch and the reward batch are the wrong shape. So if I come over here and print mask batch.shape, you can see it's size 64, and that should be a 64, it should be a batch. So we're going to go ahead and tweak a couple of these. So that is going to be, let me make sure I get the right values, parameters. So we're going to do an unsqueeze on the reward batch and mask batch. So I'm going to say unsqueeze 0 here, or actually unsqueeze 1, sorry. And then up here, we're going to unsqueeze 1. And now, if I run my program, I get a 64 by 1. It is now treating it as the appropriate shape. I can get rid of this print. I'm going to get rid of the 2 most recent runs just because they're not complete runs and I don't want them cluttering up our graph. And now, if I run this, we should start to get different results. And I'm going to refresh. All right, so the blue line there is our most recent run. And we're just going to follow that for a moment and see if we're doing any learning now. You can do things like expand this out. I actually find that the shorter view is better. Okay, so still somewhat sporadic, but there's a little bit more shape to it. You know, you can see that we're starting to slowly inch upwards. So if I expand just this value, you can see that instead of a flat line, we have a gentle slope here. Now it's still not learning terribly well, and that's okay. We have not written the entire, the entire algorithm here, but it's at least showing some direction. It is attempting to learn something, whereas before it wasn't because of those shape errors. So the next thing we want to do before we make any other training changes is we want a way to test the agent. You know, you can sit there and play with hyperparameters and tune things, but if you don't understand what the agent's actually doing wrong, it can be a challenge to figure out what to change about it. So next up, we're going to go ahead and start working on a test method alongside our train method. So down here, we're just going to def test, and this will take self env episodes, and we'll default that to 10, and max episode steps, and we'll default that to 500. That'll be a useful value later, even though right now we're mostly using 100 episode blocks. All right, so for this one, we're going to say for I episode, and this will look a lot like our train method in some ways, but there are some differences, so we're just going to type it out separately instead of trying to copy. For I episode in range episodes, we're going to say episode underscore reward is equal to 0. Episode steps is equal to 0. Done is false. And then we're going to grab a state from, and notice my underscore there, so state underscore from env.reset. All right. Then we can say while not done and episode steps less than max episode steps. And we can say action equals self.selectAction. No. Self.selectAction. State. Next state. Reward. Done. Underscore for our unused values equals env.step action. So we'll take our step. We will go ahead and increment episode steps plus equals 1. If reward is equivalent to 1, then we'll say done equals true. And this is not something we did in the main loop. With this behavior, as soon as it gets to the reward, it will go ahead and end the episode. Without this behavior, if it gets to the reward, the ball will sit there and sort of hang out on the target. So I prefer to do this for testing purposes just because it lets us get through many test runs quickly. But during training, you actually want it to be able to sit there and accumulate that reward over time because it actually helps it learn quite a bit better. So we'll do episode reward plus equals reward. So we'll go ahead and include this steps reward in episode reward. And then we will say state equals next state. And we will print out some output. Let's do F, do an F string there. Episode, episode, episode steps will be episode steps, reward will be episode reward, and that is all. Okay, so we have our test method. Now you could do a few different things here. You could either make the main.py variable so that it calls the different methods depending on what parameters are passed in. I found for my workflow it's a lot easier to just have main.py be the training code, and then have a separate test.py that actually evaluates the agent and lets me see what's going on. So we're going to create test.py, and I'm going to copy some of the things from main.py. So we're probably going to grab everything down to, we'll just say the agent, and copy it over to test.py. All of this code is pretty much going to be identical. So we'll need to make a couple of changes here. We're going to say under gym.make, we're going to say render mode equals human, in quotes. And that will help us actually see what's going on. The agent stuff will stay the same. We're going to, this time, because we're evaluating, we're going to say agent.load checkpoint, evaluate equals true. And then agent.test, env equals env, episodes equals 10, and max episode steps equals, we'll do 200. We'll give it a little longer. And then env.close. And that is really all we need here. Let's go ahead and run this. And we can see what's actually happening. So our agent is the green ball, and we can see it kind of bumbles around a little bit. And sometimes it's smart enough to find the red ball, but not very often. For the most part, it just kind of runs into corners and gets stuck and hangs out there. So not a terribly smart agent, especially when the entire state space is just this, square maze. This should not be hard for our agent to solve. So in the next lesson, we're going to go ahead and start playing with the Intrinsic Curiosity model or module that's going to give our agent a little bit of a reward just for exploration, for seeing new things, and see if that improves our performance. So I will see you there.